This used to be one of my favorite plants, a ZZ Akebono with a creamy yellow variegation, leaf after leaf. It looked like it had been hand painted. And now it's completely green. Not even a trace of yellow left. Well, okay, maybe there is a little bit of a smidge of yellow, but you get what I mean. And no, it hasn't had any pests. There's been no neglect. There've been no major changes in its care. So why has the variegation disappeared? And maybe the better question is, can I get it back? Let's talk about the timeline of this plant. Let's start with the basics. What actually happened here? I bought this ZZ Akebono in November 2023. It looked amazing, consistent yellow striping, even on the new growth. Then in December 2023, I moved it into Leca. The transfer went smoothly. No signs of shock or root loss. If you haven't seen that video, check it out linked up above or in the description below. Over the next few months, the plant continued to grow, and while the variegation slowly softened, it was still there, especially through summer and into early autumn. By December 2024, I noticed the newer growth coming in a little bit greener than before. And at that point, I thought, maybe it's just a temporary shift. But by June 2025, it is almost all green, like completely. A few yellow stripes here and there, but mostly green. Same setup, same lighting, same nutrients. The only thing that's changed really has been the seasons and the amount of time it has spent in my basement. I think the most specific, significant change really has been temperature. Before we get into what's happening with my ZZ Akebono, I want to quickly walk you through the different types of variegation you might see in houseplants. Not all variegation is the same, and that matters when it comes to understanding why it fades or disappears. Number one is chimeric variegation. This is the most common type you'll see in plants like Monstera albo, Philodendron floridogos, and yes, the ZZ Akebono. Chimeric variegation happens when some layers of the leaf have cells that can produce chlorophyll. That's what makes the leaf green, and others can't. So those parts show up white, cream, or yellow. The key thing here is that this type of variegation is often unstable. It can fade, revert, or change depending on light, temperature, and other conditions. The second variegation is the pattern gene or natural variegation. This type is coded into the plant's DNA and shows up as asymmetrical or predictable patterns like the silvery veins on a watermelon peperomia or stripes on a calathea. It's generally stable and doesn't revert easily because the plant is programmed to grow that way. Number three, reflective variegation. Some plants look variegated because of tiny air pockets in the leaf layers that reflect light differently, like in Scindapsus pictus. They're still fully green underneath, but they appear silver or shimmery on the surface. This type isn't caused by a lack of chlorophyll, so it's not the kind that fades because of stress or nutrients. Number four, viral variegation. Certain plant viruses cause irregular mottling or streaks of color. It usually affects overall plant health, so if you see this kind of variegation, you'd also see other signs of trouble like stunted plant growth or curling leaves. Number five, environmental variegation. This isn't genetic at all. Sometimes a nutrient deficiency or exposure to light stress can cause pale patches or streaks, but they're usually temporary and not true variegation. Now, in the case of my ZZ Akebono, the variegation appears to be chimeric. Some cells in the outer layers of the leaves don't have chlorophyll, so these areas appear yellow instead of green. The green parts still photosynthesize normally, but the yellow areas don't really, which is why it stands out. And because it's chimeric, the expression of that pattern can change depending on growing conditions, which is exactly what I think is happening here. Environmental factors like light, nutrients, and yes, temperature can influence whether variegation shows up or not. My working theories. So now that we know the different types of variegation and that the kind that my ZZ Akebono has can definitely be affected by growing conditions, let's take a step back and ask, what actually changed in this plant's environment over the past year, or 6 months. Because if it was happily variegated in December and now it's completely green, something shifted. I've narrowed it down to 2 possible factors. Let's break them down. Theory number 1 is nutrients. Moving a plant from soil to leca means switching how it gets fed. In leca, the nutrients are delivered in water. There's no organic matter breaking down slowly. There's no buffering from the potting mix. It's more direct. Some growers say that high nitrogen levels can push a plant to produce more chlorophyll, which might explain a fade in variegation. But I've kept the feeding consistent. Clonix clone solution at the start and then foliage focus and root zone additives. I don't think there have been any huge spikes in nitrogen that I am aware of from the time I transitioned the plant in December 2023 till now. And all my other leca plants, many of them variegated, are doing fine. There's been no reversion. So while nutrients might play a role, I don't think they're the main factor here. Theory number 2, temperature. This feels like the more likely explanation to me. The plant has been living in my basement grow space, which stays much cooler than the rest of the house, especially during winter. Even though it's under a grow light, the room itself isn't very insulated. And at night during the coldest months, temperatures down there can drop to even less than 10 degrees Celsius, sometimes a lot lower than that. And this is important. This is the first time I've lived in an older home with such poor insulation. And in all the other places I've lived, the indoor temperature was more stable even in winter. My grow spaces were sealed, they were warmer, and they were much more consistent. Now, compare that to where this plant likely came from, a commercial nursery. It was probably grown in a warm, controlled environment where conditions were ideal for the variegation to fully express. So when I brought it home, moved it into leca, and then placed it in this much colder space, it didn't react immediately. The change has been gradual, which is part of why it took me so long to realize that it was happening. Could months of cooler temperatures have slowly pushed the plant to stop expressing its variegation altogether? That's the question I keep coming back to. I couldn't find any published studies specifically on the ZZ Akebono or even on variegation in the ZZ plant, but I did look into research on other variegated plants. And while they're not a perfect match, they do reveal some interesting patterns that might help explain what's happening. Let me walk you through 2 studies that stood out. The Pittosporum tobira by Zhang et al. In 2019, published in the International Journal of Molecular Sciences. This study compared a variegated cultivar of Pittosporum tobira to its all-green counterpart, with both grown under sustained low temperatures, around 10 degrees Celsius. What they found was that the variegated plants maintained their color and coped better with cold stress than the green ones. They didn't develop more variegation, but they didn't lose it either. And they actually showed a stronger antioxidant activity under cold conditions. So in that species, cold didn't cause a reversion. It had no negative effect on the variegation at all. But of course, a Pittosporum isn't a ZZ plant. It has a different growth pattern, a different leaf structure, and possibly a different type of variegation altogether. Which is why my ZZ Akebono might be reacting differently. For one, the cold that it's experienced has been both more extreme and more prolonged. In my basement, it can drop to 10 degrees Celsius or lower at night for weeks at a time. And unlike the Pittosporum, this plant isn't just adjusting to cool conditions, it's adjusting to a long cold season in an uninsulated space, far removed from the warm controlled environment of the nursery where it was likely grown. So instead of holding on to its variegation like the Pittosporum did, my ZZ Akebono may be switching to solid green growth as a survival response, a way to maximize chlorophyll and photosynthesis in a tougher environment. The second experiment was conducted on the Arabidopsis thaliana variegated mutants by Sakamoto, published in 2003 in Genes and Genetic Systems. This second study looked at genetic variegated mutants of the Arabidopsis plant. These plants had mutations that disrupted chloroplast development, causing patches of a white or pale green on their leaves. This is a classic variegation which is caused by a lack of chlorophyll. But what makes this study so compelling is what happened under different environmental conditions. Even though the mutation was always present, the actual appearance of the variegation changed depending on temperature and light. In some conditions, the plant showed strong, obvious variegation. In others, under different temperatures or lighting, the exact same plants grew leaves that were almost fully green. This tells us something really important. Environment alone can determine whether a plant expresses its variegation, even when the genetics stay the same. So when I look at my ZZ Akebono, knowing that it likely has a chimeric variegation, which is already considered unstable, this study gives me a strong reason to suspect that temperature could be the main factor behind the change I'm seeing. So what do these studies tell us really? They both show that temperature matters, but not in one simple, predictable way. In the Pittosporum, the cooler conditions didn't harm the variegation at all. In the other experiment, cooler conditions could suppress it entirely. There's no one-size-fits-all answer, is what I'm gleaning from this. But what they do make clear is that a change in temperature can absolutely affect whether a plant expresses variegation, even if the genetic capability is still there. Which brings me back to my ZZ Akebono. It may still have the genetic structure for variegation, but after months of sustained cold in an environment very different from where it was grown, it might have simply shut down that expression, choosing to grow solid green instead as a more efficient and stable way to survive. And the big question now is, if the temperature changes, will the variegation come back? That's what I'm hoping to find out next. At this point, I've done a lot of thinking and reading, and I'm still not sure what caused this. If you're a plant physiologist, botanist, pathologist, or even just someone who's experienced this kind of reversion, I'd love your take. Could this be a temperature response? Could nutrient uptake in Leca be part of the picture? Or is something else going on entirely? I'm not planning to take a cutting off this plant, but I am considering moving the whole plant upstairs into a warmer space for the rest of winter and into early spring, just to see if anything changes, if the variegation starts to come back, and that might give me a clue. So if you've seen something similar or have any thoughts at all, please drop them in the comments or come join the conversation in my Facebook group, Semi-Hydroponics with the Leca Queen. I really want to hear from others on this. It's a bit of a mystery and I'd love to know what you think. To see where all this started, watch the video where this exact ZZ Akebono was moved from soil to Leca. It shows the full step-by-step process, including root cleaning and potting up in Leca. You'll find the link on the screen and in the description below. See you in the next one.